In this video, we're going to be taking a look at understanding percents, and you'll need to have your Go Math book out and turn to page 203, your math journal, and a pencil. Now, the essential question we're going to be taking a look at today is how can you write a ratio as a percent? So let's look at the Explore activity number 1. It is important to know that a percent is a ratio that compares a number to 100. It's always compared to 100. The symbol percent is used to show a percent. So for example, looking here, 17% is equivalent to 17 over 100, 17 to 100, and also 17 to 100, just like that. And we can see that the free throw ratios for the three basketball players are shown. 17 out of 25, 33 out of 50, and 14 out of 20. Now what we want to do is rewrite each ratio as a number compared to 100. You can see this would not be 17% because it's not compared to 100. This would not be 33% because it's compared to 50, and this would not be 14% because it's compared to 20. A ratio or a percent has to be compared to 100. So what we can see is if we're going to rewrite each ratio as a number compared to 100, then we're going to shade the grid to represent the free throw ratio. So you can see with this, we need to figure out 25. What do we need to do to get that to 100? We multiply by 4. So because we multiply by 4 for the 25, we multiply by 4 for the 17. I want you to write 68 out of 100. 50 we multiplied by 2. Multiply 33 by 2 for 66 out of 100. And then multiply the 20 by 5 to get to 100. Multiply 14 by 5, and that gives you 70 out of 100. Then what we can do, we can shade in each box, and then you can see what this represents. So 68 out of 100. So we could say that 17 out of 25 is 68%. So if we take it out of 100 there, it would be an equivalent proportion to 68 to 100. So what I'll have you do is shade in 68 of those squares within the 100 grid. For player 2, shade in 66 of those squares. Understand that each row represents 10, so you can shade in 6 rows, and then 6 of the other one. And then finally 70, we can shade in 7 total rows there. So now that we have all of our 100 grid filled in, we can see that which player has the greatest free throw ratio. We can see that player 3. Why is that? 70 out of 100, 68 out of 100, 66 out of 100. You can see 70 out of 100 is the most. It's kind of difficult to compare 17 out of 25, 33 out of 50, and 14 out of 20, but when you make it all out of 100, you can see it's very easy to compare. So greatest free throw ratio, player 3. Right, player 3. There we go. How is this shown on the grid? How can you see this on the grid? It's easy to see that it's the most squares shaded in. I want you to write that down. The most shaded squares. So most shaded squares. Now not finally, but for letter C, it says use a percent to describe each player's free throw ratio. Write the percents in order from least to greatest. So percents, just like whole numbers, easy to tell from least to greatest. So we can see player 2, 66%, had the lowest free throw percentage. Then 68% for player 1. And then finally 70% for player 2. How do we know that 70%? How do we know it's 66? How do we know it's 68? Because it's compared to 100. The ratios at the top here, 17 out of 25, 33 out of 50, and so on, those are not compared to 100, so it's difficult to find the percentage. But once you compare it out to 100, you can see 70 out of 100 is 70%. Pretty easy to see there. Now for letter D, how did you determine how many squares to shade on each grid? I want you to write this out. Write equivalent ratios whose second term is 100. So you can see first term is 66, second term is 100. The first term tells how many squares to shade in out of 100. So that's how you can determine how many squares to shade in on each grid. Okay, let's turn your books to page 204 now. And it says connecting fractions and percents. It says you can use a percent bar to model a ratio expressed as a fraction and define an equivalent percent. So it says for letter A, it says use a percent bar model to find the equivalent percent for 1/4. Draw a model to represent 100 and divide it into fourths and shade 1/4. So we can see that this bar represents 100%, the total bar here. And why do we divide it into fourths? Because we see that we need to represent 1/4. Okay, so we have to divide this bar into fourths. And then what we could do from here is we could shade the bar in. All the way there. And then we can see that 1/4 of this is shaded in, which would equal 25%. And you can write that right in the box there. So 25%. How would we know that's 25%? Because we can see 1/4 would be 25, half of it would be 50, 3/4 would be 75, and the full would be 100% there. So 1/4 of 100 equals 25. So 1/4 of 100% equals 25%. Now the next question says, tell which operation you can use to find 1/4 of 100 whenever you see something of. That of most of the time means multiplication. So 1/4 times 100. Then find 1/4 of 100% is going to give us 25%. So operation multiplication, 1/4 times 100% equals 25%. Now, the next one says use a percent bar to find the equivalent percent for 1/3. Draw a model and divide it into thirds. Why is it into thirds? Because it's 1/3 that we're finding. Okay, so you can take a look at the second term there, or the denominator. We know it's divided into 3 equal pieces now. So we have 1/3. We can shade that in. We know that 1/3 of 100% is going to give us 33 and 1/3%. Okay, so we can see 1/3 of 100 equals 33 and 1/3. So 1/3 of 100% equals 33 and 1/3%. Once again, tell which operation you can use to find 1/3 of 100. Then find 1/3 of 100%. Operation, we use multiplication. 1/3 times 100% equals 33 and 1/3%. So let's take a look at the reflect question at the bottom. It says Joe says she can find the percent equivalent of 3/4 by multiplying the percent equivalent of 1/4 by 3. How can you use a percent bar to support this claim? Okay, so what we can see here, it said shade 3 1/4 sections to show 3/4. And then since 1/4 equals 25%, 3/4 equals 3 times 25% equaling 75%. So you can take a look at the model up at the top. You can shade it in 1, then you can shade in 2, and then shade in 3 total, equaling 3/4. And since we know that 1/4 equals 25%, 3/4 equals 3 times 25. So here's a 25, here's a 25%, and here's a 25%, equaling 75%. Now let's take a look at page 205. It says using benchmarks and proportional reasoning. Now it is important to understand that you can use certain benchmark percents to write other percents and estimate fractions. So you know 1/10 equals 10%, 1/4 equals 25%, and so on. So just be familiar with these benchmark percents here. So let's take a look at example 1. It says find an equivalent percent for 3/10. So we know that 3/10 equals 3 times 1/10. So in other words, think 3/10 equals 1/10 plus 1/10 plus 1/10. And since we know that 1/10 benchmark percentage equals 10%, we would know that 3 of those 1/10ths would equal 30%. Now let's take a look at letter B. It says 76% of the 76% of the students at a middle school bring their own lunch. About what fraction of the students bring their own lunch? So if we're taking a look at estimating here, we note that 76% is close to the benchmark 75%, which is right here. I know that 75% equals 3/4, and so about 3/4 of the students bring their own lunch. So even though it's a little bit more than that 75%, we know that 75%, the benchmark fraction for that is 3/4, so we could say about 75%. So let's take a look at number 2 at the top where it says your turn. It says use a benchmark to find an equivalent percent for each fraction. So if we take a look at 9/10, first of all we need to think about 1/10. We know equals 10%. So if I have 9 of these 1/10ths, we can take 10% times 9 is going to equal 90%. Okay, so the benchmark to find an equivalent percent for the fraction would be 90% there. So let's take a look at number 3 now. We could take a look at 2/5. Think an equivalent fraction of 2/5 equals 4/10. Okay, so since an equivalent fraction, I said 2/4, 2/5 equals 4/10, I know that 1/10 equals 10% again. And then 4 of those 10% is going to give me 40%. So let's take a look at number 4 now. It says 64% of the animals at an animal shelter are dogs. About what fraction of the animals at the shelter are dogs? So I know that 64%, taking a look at page 205, is very close to 66 2/3%. So since we're taking a look at an estimate, not an exact answer, we could say that since it's close to that 66 2/3, we could say about 2/3 of the animals at the shelter are dogs. So now I want you to take a look at the guided practice on page 206, and I want you to answer number 1 and also shade in the grid that represents 9 to 25, the ratio 9 to 25, and you can work on number 1 now. So the answer you can see is 36%, and you should have 36 of those squares shaded in. Now what I would like you to do is work on number 2. You can work on that now. So you can see that the answer for this is 20%. Now I would like you to work on number 3, and you can work on that now. Okay, so the benchmark would be 1/10, and the answer would be 60%. And the final one I'd like you to work on is number 6, and you can work on that now. So you can see the benchmark fraction that was used is about 2/5. So we can see the answer for that is about 2/5. So wrapping up the video, take a look at the essential question. How do you write a ratio as a percent? Write the ratio as a fraction, then write an equivalent fraction with a denominator of 100 and change the fraction to a percent. So this concludes the video on understanding percent. If you have any questions about this concept, please come and see me.